Today we're going to do titanium alloy sorting. We're going to show you the new SciAps XRF we've been talking about, but we're going to focus on titanium alloys. So the first point to make about titanium alloys is most of them, almost all of them in fact, you can sort with a single beam test. So we're going to show you this thing doing that in 2 seconds. Then we're going to show you a couple of alloys you actually need to see aluminum or silicon in order to separate. And we'll show a two-beam test. So what we're going to show you is you can sort with this analyzer 99% of your tie alloys in about 2 seconds, and the rest of them, when you need to measure low aluminum, low silicon, you can do that in a total of 5 seconds. So again, it's that really fast handheld XRF design that we've got with the new detector technology, the new pulse processor, and the really small, powerful X-ray tube, and the great geometry. So here we go. Let's just start taking some stuff and shooting it. Do this one. So these are all 2 second tests. 2 seconds, you get your 325. There you go. You see that. Let's go with it. What's this one? CP. We'll get back to that one. Another one. Let's see what this one is. There's your 6211. So there you see that it's about 1% tantalum. That's not a real common tie alloy. Two niobium, 1 tantalum, but there you go. And then, okay, let's go to a few harder ones. This is a really good one. Let me find my grade 7. Here it is. So let's go to a grade 7. Again, 2 seconds. And the key to seeing this in 2 seconds is the palladium, which you see about 0.16%. Just so you wasn't lucky. Let's do it again. There's your palladium. Do it one more time. Palladium. There you go. So there's your palladium test, and that's a grade 7. An even harder test in 2 seconds, the one that works quite well with the unit, is grade 16. So we'll do grade 16. There you go. 0.0506% palladium in 2 seconds. That's a hard measurement for almost any other handheld XRF. We'll do it again. There you go, 2 seconds, your low palladium for your grade 16. So you see you got your palladium, you got your grade, and then just to show there's nothing funny going on, there's those darn radiation rules. Here's the total CP tie, 100% titanium, no palladium. So there's a few more we can do quickly here. Another fairly easy one to do, 662. So I'll just run through a few more here. Here's probably one of the most common ones you'll ever see other than CP. That's your 6.4. That's your 6.4. And then a couple of little less common ones. 1023. There's your 1023. And then your 811. There's your 811. So there we go. That is really, there's other tie alloys, but the key takeaway here was 2 seconds, and you're getting all these things sorted. Even the grade 7, which is 0.16 or so palladium, and down to the grade 16, which is 0.05, 0.06 palladium. Now we move to the beam 2. It's very easy to change that. So in some cases, you need to see aluminum or silicon to sort some of these alloys. So what I want to show is how you can, in a total testing time of 5 seconds, you can measure the silicon or the aluminum at the levels needed for all these tie alloys. So let's go, first let's put this thing into a dual beam test. Done that. So let's show this first one, which is, this is a 4.4 2.5. This is about a 0.5% silicon. So let's see, 5 second total test time. So 2 second beam 1, 3 second beam 2. So it goes to 2 seconds. Oops, hit the trigger. There we go. It does. After 2 seconds, you get your ID. Now it's going to flip over to the second beam, and you see you're going to measure your silicon down around a 0.5% or so. They're all done. 5 second test, you got your silicon. In this case, it had about 4% aluminum. Let's show one more. that one. Got the old man glasses. Let's find it here. This is much faster if I have these on. Let's do these two. So this is another good one. This is a CP tie with about 0.3 or so% aluminum in it. So same thing, in 5 seconds total test time. So after the first 2 seconds, it knows it's CP, and then it'll pop over to beam 2, and you see literally in less than 5 seconds, you got your 0.3 aluminum right there. All right, and there we go. So that's really the gamut of the testing right there for titanium alloys. Again, 2 seconds for almost everything, even that really challenging 0.06% palladium in grade 16, and then you can get your 0.5% silicon, your low aluminum, no problem, in a total 5-second test. So 5 seconds is really rivaling a lot of these arc systems that are used for titanium alloy sorting, but this is a little longer, 5 seconds. But this will do your 6242 and your 6246 because it's very, very good on moly, zirconium, some of those other high temperature alloy elements. So this is what it means for business in terms of sorting tie alloys. What we showed is if you don't care about low silicon and low aluminum, then you can sort all these tie alloys in 2 seconds with this XRF. And what that, the other X-ray models, they might take longer on those grade 16 and those grade 7 alloys because of the low concentrations of palladium. This can do them all in 2 seconds, which means your sorter can just be running 2 seconds all day long. It doesn't have to worry about, well, this alloy I need to do 5 seconds or 10 seconds, but that one I can do in 2. So what it means, if you can do everything in 2 seconds, nobody has to worry about it. It's easy to use, and the productivity is many times greater. So you can sort a lot more tie alloys, which are expensive, a lot faster because you can just do everything in 2 seconds. And that is a very big throughput advantage when you're either verifying tie alloys for shipments or outgoing quality control or scrap sorting or incoming material sorting.